Our textbook gave in the previous subsection the example that if the sine of pi over 6 equals 1/2, then the sine inverse of 1/2 equals pi over 6. And this is an example of inverse, right? If we have an angle as the input and a ratio as the output for a function, then the inverse function is going to have the ratio for its input and the angle for its output. But these two pieces of information go together, right? This is the x value, this is the y value. This is the x value for the inverse, and this is the y value for the inverse, because what an inverse does is reverse the roles of x and y. I can do the same thing with cosine and tangent. If we know that the cosine of pi over 3 equals 1/2, then the inverse cosine, sometimes called cosine inverse of 1/2 equals pi over 3. What used to be an x comma y input comma output relationship is now, well, it's still input output, but it's y comma x, right? Because this is an inverse function. Let's try one with tangent. I know that the tangent of pi over 4 is equal to 1. That means that the tangent inverse of 1 is equal to pi over 4. There are an infinite number of these that I could do. I'm just going to do one more to kind of make a point. Let's see, do I want to do sine, cosine, or tangent? I think I'll do a cosine one. The cosine of an angle equals a ratio. And the thing is, I can pick any of my nice angles and put it here. And hopefully, if it's one of my nice familiar angles, 30, 60, 90, 0, any of the multiples of those, if that's what goes here, I should know what the ratio is that I get there. And that means that the cosine inverse of the ratio is going to be my angle. This is the angle, this is the angle. This is the ratio, this is the ratio. So, cosine of, how about pi over 4? I know that to be the square root of 2 over 2. So the cosine inverse is the cosine inverse of the square root of 2 over 2 equals pi over 4. And it's just that simple, except when it's not. The sine of, let's see, 4 pi over 3 is equal to, let me draw a unit circle. There's 1 pi over 3, 2 pi over 3, 3 pi over 3, 4 pi over 3. This is 4 pi over 3, and I want the sine of that angle. So I'm going to use the reference angle, pi over 3, to take the sine of pi over 3, and I know the sine of pi over 3 to be the square root of 3 over 2. So that's going to be the numerical part, the square root of 3 over 2. And then I need to figure out what quadrant I'm in here. All students take calculus. This is a t. Sine is not positive here. That means it's negative. So my answer here is going to be negative the square root of 3 over 2. So one might argue then that the inverse sine of negative the square root of 3 over 2 was equal to 4 pi over 3. But it's not. And here's why. Remember in the previous video where we said that the sine of x, in order to be considered as a candidate for having an inverse, had to be restricted so that x was between negative pi over 2 and pi over 2. If we want to talk about inverses at all, we have to restrict the domain. This is going to be true for all of our trigonometric functions, but so far we've only looked at the inverse of sine, so I'm going to talk about it from that perspective. If I have to restrict the domain for sine from negative pi over 2 to pi over 2 in order to talk about its inverse, let's take a look at what that looks like on the little mini graph that I've drawn down here. Pi over 2 is here, and I can go from 0 to pi over 2 in quadrant 1. Negative pi over 2 is back here. Remember, negative angles means going clockwise around the circle. So I have to work within this region in order to be able to talk about an inverse. What I have here, this angle that I have here, is way over here in quadrant 3. If I have any hope of solving this particular problem, they're often given to you in this form. In other words, find the angle for which this is true, right? If I have any hope of solving this problem or finding the value that satisfies this situation, I need to find another angle, not 4 pi over 3, but another angle whose sine is negative 3 pi over 2. Well, they're all going to have a reference angle of 60, right? Of pi over 3. So it could be this one. It could be this one. It could be this one. Or it could be this one. These angles all have a reference angle of pi over 3, just like 4 pi over 3 does. It has a reference angle of pi over 3. So it could be any of those, but in order to be a candidate, it has to be in either quadrant 1 or quadrant 4. And its sine has to be negative. Well, that puts it in quadrant 4. So now what I have to do is figure out what angle this is in quadrant 4 that has a reference angle of pi over 3, and that'll be my answer. It's not as obvious, not always as obvious as just taking the angle that you were given, right? In order to be considered a candidate for an inverse, for sine, the angle has to come from quadrants 4 and 1. So what is this angle? Well, it's 2 pi minus pi over 3, or it's 0 minus pi over 3. 2 pi minus pi over 3 would be 6 pi minus pi all over 3, which is 5 pi over 3. 0 minus pi over 3 is minus pi over 3, negative pi over 3. So one of these two angles is the answer to my question. The problem is, this one, it might be in quadrant 4, but it's not between negative pi over 2 and positive pi over 2. It's between 5 pi over 3 and 7 pi over 3, and that's not in this range. So that means we really do only have one choice here, not the two choices we thought we did. My answer is negative pi over 3. And so the answer here is negative pi over 3. Even though x and y are supposed to just change places, it doesn't always work that way. The input value here has to come from this range of values. I can still find the sine of 4 pi over 3. It's right there, negative root 3 over 2. But I can't find the inverse sine of negative root 3 over 2 unless the answer comes from the restricted domain. All right, our next topic, our next subsection in this chapter is called using a calculator or something or other. And I'm not going to do a video on that because I don't think we need one. I think most of you are going to be quite capable of figuring out how to use a calculator to get these values. More importantly, I don't really want you using a calculator to find these values. There will be times when I'm going to give you, or you will be given, angle values that are not pi over 6, pi over 4, pi over 2, pi over 3, right? They're not going to be comfortable, familiar, easy, common angles. And so there will be times when a calculator is appropriate. Will we talk about it in class? Absolutely. I'm going to spend a little bit of time talking you through how to find sine, cosine, and tangent are super easy because there's usually a button on calculators that lets you just find those values directly. Finding the cosecant, for example, is a little bit more challenging, but we'll talk about that in class. I don't want to take video time talking about that. So I'm going to skip the video on using a calculator, and our next video, our next subsection is called Finding Exact Values of Composite Functions with Inverse Trigonometric Functions. See you over there.